Hey everybody. Today on Into the Terminal, we're going to be doing another shell scripting tutorial with automating tasks. So why don't we jump on into the terminal and we will start our first one. So um, I, Nate last week in our post notes said something like, if you do it once, do it once. But if you do it twice or more, script it. And that's what we're going to be working on today. So what's something that we can do that we typically will see used pretty often, or a task that we do fairly regularly that we could automate or get better utility out of by using shell scripting? So here's my first one. A long time ago, I worked or I was on a consulting engagement. I worked with somebody who was a ops wizard for Linux, and I don't use that term sparingly. Like he could literally cast spells and summon dragons while doing Linux operations. But one of the things that he incorporated in our operations was before you messed with a file, you ran a command to back up that file, and he called it BKP. And so the first thing we're going to do is we're going to write this BKP script, and I'll show you how to do it because it'll help reduce errors on your operations and systems. All right. So the first thing we're going to do is we're going to edit our file. And I said we were going to call it BKP. So I'm going to open up a file called BKP. And we're going to start off with a hashtag exclamation part mark bin bash. Also known as the shebang. It tells us what interpreter should be used when interpreting and executing the commands in this file. All right. So what BKP does is it makes a backup copy of a file that's passed to as an argument. So as last week, we talked about positional parameters a little bit, but the first positional parameter is stored in a variable called $1. So the first thing we're going to do is we're going to add a little bit of usage and checking, because if you just run BKP without anything, it should error. So we're going to add an if statement. All right. And an if statement is structured like this. If some condition, then execute a segment of code. If the condition is not met, we should skip over the execution of this code. And there are some other variants that we saw briefly last week, like an else or an else if, where we can build more explicit control structures. So what we're doing is we're testing to see if the argument that is stored in $1 is a file. So -f is a check to see if the thing that's passed, $1, is a file. Um, so if it's a file, we should do everything else, which would mean I have to put my whole rest of my script inside of that then fee construct, which isn't really what we want. What we want is for me to put all the additional logic and everything else later on in the script, but instead, I want to check to see if this is oops, not a file. So adding the exclamation point negates the check. So if -f $1 is a file, that would be success. And then we not it, which means it's a failure, and we skip the execution of what's inside of this code branch. But if what we're passed is not a file, then we're going to do something, and we're just going to echo. Right? We're going to print a message to the terminal. And then the other thing that I'm going to do is I'm going to give them a usage diagram. Right? So this is how you should use this command. And the third thing I'm going to do is I'm going to exit the script at this point. If they didn't give me a file, then there's nothing more for me to do. So I should just exit out of this script. And then the number there um, is a return code. Normally, when a command is successful, it returns a 0 to indicate that it was successful. A non-zero tells me it was not successful. And then the actual number can mean things. So if I don't use the return code 5 anywhere else in this command or in the script that I'm writing, if I look at the return code and I see it's a 5, then I know it's because they failed this check. All right. So let's try it out. I will make it executable. And then I'm just going to run bkp with no arguments. Oh, that didn't look right. If not file, then uh, let's try a different one. Uh, let's do Etsy. All right. So we pass it a directory, and it says, "Whoop, nope, can't work." All right. So we found our first iterative improvement we need to make to our script. If there's no argument passed, it also needs to trip this error path. So what we're going to do is say if it's this or zero length. So if it is either not a file, actually I need to do that differently. That I think. If it's not a file or is zero length, then we should give the error. Let's see if that works. All right, so that works. If we don't pass anything, let me pass a directory. Cool. And if I just pass it an actual file, it should silently close because all that we have left in there, or all that we have in the script so far, is just checking to see if there is an argument that is a file. Okay, so that seems to be working. If somebody invokes the script incorrectly, they will get an appropriate error message. All right. So, but what if they do invoke it correctly and they give us the file name that they want? So what we're going to do is we're going to create a backup copy of that file. Hmm. We need to create a backup copy of the file. Well, this is actually pretty challenging because what happens if somebody just uses a local directory file, like we're in the Etsy directory when we said password, versus a full and complete path name of the directory, Etsy password? How do we know where to store the backup and what we should call the backup? So let me go back a little bit before I put in this copy. The copy is going to be the very last thing we're going to do. And I'm going to put in a little bit more structure. So I'm going to create a couple of variables. All right. And I'm going to show you what these variables do. Let me just echo uh, of file and file name. Okay. So there are these two commands, dirname and basename. When you call dirname on something, it'll cut off everything but the final bit of the path, thereby giving you the directory where that thing lives. And base name gives you the last thing on that path or the file name, right? So actually, instead of doing this echo, let me just dir name user bin um, ls. There we go. So when I do a dir name on user bin df, notice that it gives me everything that's the directory in front of the actual file that I'm interested in. And if I do a base name user bin df, it gives me that last part. All right, so I now know the directory and where it is. If I'm in, let's say user, and I'm referring, let me clear the screen here, and I'm referring to this as uh, dir name bin df, right? Notice that it still behaves correctly, or base name bin df, right? So it takes whatever path I was given and it cuts down to be just the directory location of the end file or the file itself without all the directory stuff. All right, now here's why this is important and why I created those variables. What we're going to do is we're going to store our backed up file inside of a hidden directory inside of where that file lives. So we're going to check if dollar. All right, now there's a bit of magic here because I'm root executing the script, so it can create directories wherever it wants. So if I was trying to make this available for regular people, I probably have to mix in some sudo rules and some other things. All right, so we're going to create a hidden directory called backup inside of wherever this file lives. So if it's an Etsy, there will be a hidden directory called .backup inside of Etsy. And then we're going to copy our backup into that hidden directory. So we're going to copy $1. Whoops. And let me create one more variable up here to make things a little bit easier to read. All right, so when we make our backup, we're going to put it in the directory where we're backing up this file. We're going to put it in this hidden .backup directory. I just set that as a variable, so we're not using it yet. And then I check to make sure the backup directory exists. And then I can go ahead and perform this copy. All right, so I think that'll work. All right, the moment of truth. If I do a BKP, Etsy, HTTP, conf, http.conf, what should have happened is if there is a .backup directory inside of Etsy http.conf, we'll see a file copy in there. If there wasn't already a .backup directory in there, it should be created, and then our file copy should be placed in it. So if I list Etsy http.conf.backup, there it is. That's the backup that I made before I edit this file and change it. But you know what happens if I sometime later do a BKP again and make another backup copy? It would overwrite this one because they have the same file name. Or maybe somebody else was working on it and they did the same thing and they overwrote my file copy with their file copy. So we're going to go one extra level and we're going to use some command line foo to make this file name more distinct. What we're going to do is when we make the copy, we're going to put on uh, the user's name that made the copy. And we're going to put a date and time as part of the file extension on this copy. So we're going to use the 4-digit year, the 2-digit month, the 2-digit day, and it could be that we're making multiple copies in a day. So we want to make, again, it unique enough. So we're going to also add in the hour, minute, and second that the BKP command was run. And that still might not be quite exact enough. So we're going to put in also the nanoseconds of the second that gets logged in this file. All right. Okay. and good. All right. So we're going to back up Etsy HTTP HTTP.conf. Cool. No errors. That's good. All right. Ooh, and I have a typo because notice it says Y instead of the actual year. I didn't put a percent in front of it. There we go. Let's try one more time. Okay, so finally we've got it right. This one right here. So we see our name of the file, http.conf. That root was the one that made the backup copy. Here's our ISO formatted date, our hours, minutes, and seconds of time, dot the nanoseconds of time. And so as long as I'm not making one copy in the same nanosecond, um, it'll make sure that the copies are distinct and different. All right, but there's one more challenge that we got to fix. So right now, this BKP script lives here in root's home directory. Not a great place. And I would say that not only root should make backup copies of configuration files before they edit them, but everyone should. So I'm going to copy that to user local bin. So user local bin should be on people's path environment variable, meaning if they type a command at the command line, it's one of the directories that gets checked for that command. So instead of telling it dot slash, it's my current working directory, I can just now use it as a bare command. If I move somewhere else, I could still run BKP because it's found in my command line path directories. All right, and then I can make a backup copy of conf http.conf. Because I changed my directory to be locally working directory path. And when I ls, right, it still works correctly right here. There's my backup copy. And thanks to it being in user local bin, regular people could also do this. Now, if I wanted to allow regular people to make copies of Apache configs in directories that regular people don't have write access to, again, I probably want to mix in some sudo magic. Not only sudo, maybe allow sudoers to have access to the BKP command, which would allow it to run with root privilege. Um, and that would get me around that. All right. So why would we do this? So let's say we edit my configuration file. And and you know what? I'm really bad with VI, and I'm coming in here and I'm like, oh, I messed the thing up. Hold on, let me quit without saving. Oh no, I wrote quit it. Oh, it's dead to me. Right, right. That's it. It's gone. Well, thankfully, here's my backup copy, so I can just restore it back to its initial state before I messed it all up. Right. So um, my friend Chen, the operations wizard, literally like drilled into the whole team. Before you edit a file, any file, you run BKP on the file and then you edit it. That way, if you mess it up during editing or something weird happens, you have a backup copy. And then anything else that you're doing with the file that you might want to save its state of, you run BKP first, and then you have a backup copy. Um, so that's a tool that one can write to help their operations to automate those tasks of making sure that we don't mess stuff up in shell scripting. All right, BKP. All right, so that was a little bit long. We will, after the transition, write another script. We will be writing a script that checks for the versions of software that we have. And we'll actually mix in some SSH so we can actually check more than one system with our script. So stay with us. Don't forget to mash that like and subscribe, and we'll see you on the other side. All right. So now is the part of the program where we look at the questions from the audience. Um, if you are a deferred viewer, please feel free to leave your questions in the comments, and we'll get back to them. Um, Nate and myself do a pretty good job about answering comments when they come in. So we saw a bunch of stuff there in the critical path, but I think the most critical things are put your commands in the file, do a little flow control, right? We used the if statement to do that flow control to like check to make sure the state is what we expect before we did a task. And then the other thing that you may have picked up on is build your lexicon of commands. Base name, dirname, where the heck did those come from? Well, you figure it out, right? You do some Googling. Hey, here's the task I'm trying to do. And usually there's a command or a command with arguments that will help you get there. Um, and then you add that to the list of commands that you know so that the next time you're writing the script or you need to do that thing, you know it. For example, like I didn't know that printing a file in reverse order was a thing, but tac is the opposite of cat. It prints the file in reverse order. Who knows? But I've used it now a few times in things like automation because it's easier to try and reverse a file and look at it from the bottom up instead of trying to look top down to a certain point and then care about the stuff after that. So you pick up these little like tricks and ways of doing things because you've grown your command vocabulary over time. But don't be too intimidated because we all started with not a lot. I've just got a lot of years under the belt on getting this done. All right, so let me do a quick look um, on our questions. Oh, I see Shantanu let me know that he's here to make sure that I get corrected anytime I make a mistake, unlike last week where he was not here and I made a mistake and it went uncorrected. Um, Vincent had a really great idea that maybe in addition to the backup copy of the file, you also snap a MD5 sum of the file so that your backup hasn't been changed. In fact, the original BKP program that I was kind of loosely reliving or recreating did that. The other thing it had was a restore option. So you could actually go in and restore your command using or your file using BKP instead of having to manually surf and look at it. So there's a lot of like additional changes that you could make to this utility that we just made to make it even nicer and have even more features and do things like account for other weirdnesses, like somebody modifying your backup file by accident. All right. Yeah. And then Shantanu also said that you can use set so that you can actually watch the script execute. Set-show pipe fail lets you pipe it into something and it results in a failure message. We'll actually get to like messaging and a couple other things in this next example. All right. So back into the terminal. For our second example, here's the situation. Hey, uh, we need to make sure that this software that's installed on our machines, or at least on some of the machines, is the right version. How can we do that? And this will have a couple of different iteration of questions, right? One might be for licensing. Hey, what machines have CrowdStrike installed on them and what version? Or it might be vulnerability mitigation. Hey, there was just announced a vulnerability for this package. What machines are susceptible to that vulnerability, right? So you got to go out and like figure out what machines are out there that have the vulnerable version of the package. Um, so we're going to write a small program to do that stuff. All right, so let me go back to my home directory. And we're going to make um, package test. All right. And you may have noticed that when writing a script, I use a programming style that I would call iterative programming, right? I write a little bit at a time, I get out of the editor and I test it. And then I fix any problems that I might find. Then I go back in to make my next enhancement or to make the next segment of the script that I know I need to work. And the reason I do this is because if you sit there and you write this big, long, huge, tens, hundreds line script, and then when you're finished, you test it, man, sometimes it's really awful to find that quote that you missed or the closing parenthesis that you missed, or you have multiple mistakes and you get to troubleshoot it. So when I'm doing programming, I do iterative programming. All right. So here's what we're going to do. We're going to pass to the script two arguments. The first argument is going to be the package name that we want to check. The second argument is going to be the version string that we're looking for this package. All right, so just like before, actually, we're going to be less nice to do error checking. Let's just say this $1 and target version equal $2. All right, so to keep this a little bit more simple, I'm just going to assume that they invoked it correctly. That the first argument on the command line is the package name they're looking for. The second argument on the command line is the version that they want to have installed on the machines. Now, we could go in just like we did with BKP and do some if-then checking to say, hey, if this argument wasn't passed, what should I do differently? Should I error? Should I change behavior? Should I exit? But we're just going to assume that they're calling it correctly. All right, so let's do rpm-q $1. Right, so let's query to see what this version or this package is. So we're going to add the execute permission to it. And we're going to check the less package. So I picked this to make our example work here because I happen to know that there is an update available for this machine for the less command. So currently on this machine, it's running less 590-3. But if I do a DNF list updates less 590-4 is available for these machines. What I want to do is I want to survey my machine population to see who has the old version and who has the new version. So um, we're going to query this for our package, and that'll tell us what version it is. And then we're going to make a choice. So mm, man, let me go over here to the client real quick. It's nice to have two machines because you can actually work in two windows. Although I guess I could have just used tmux. All right, 590-4. Is that right? .el9 underscore, whoops, el9 underscore 4. Yeah, cool. All right, so let me get out of this real quick and let's take a look at our output. So when I do an rpm-q less, it tells me the package name and then that, right, the version and release number, and then the architecture. So if I just say if if the output of RPMQ equals this, right, that's not going to work very well. Let me go ahead and flesh out my logic a little bit. All right. So what we're looking for is to test to see whether the package I have installed is equal to this version I want. And in fact, I should put it in the as an argument. It's already stored in a variable. So if it's equal to the target version that I want, if that's true, the version I have equals the version I want, prints OK. If the version I have isn't the version I want, it prints fail. But this isn't going to work very well because that. Oh, and it helped if I pass the right version. Hold on 1 second. 594 EL 94. All right. Still doesn't work very well because when I did the check, it just looked at this string. Does this string equal this string? No. The second one has a whole bunch more stuff in it, right? It's got the package name, it's got the architecture it was built for. So of course the two strings aren't equal to one another. So here's where we could do some of the tricks we did last week. So last week we actually strung together a whole bunch of commands with pipes to take a piece of output and then grep to match only a certain amount, or we could use things like sed, which is a stream editor to cut off certain pieces of it, or we could use tools like cut to chop up our output and then only select certain bits. So you could do it that way. Um, and that would be perfectly fine. But I happen to know through my command lexicon of building over the last 25 years that the RPM command can actually customize the output that it provides to be something different than what is shown here on the screen that I've got highlighted. Instead, we could actually ask the command, instead of querying and giving me the name, version, release, and architecture, just give me version. So if we go back up here and we change this command that we're doing to include, whoops, to include, here's what I want the output of the query to look like. And this is documented in the RPM man page, by the way. Okay. So we're going to query. We tell it we want the output to be version and release, and we want that to be based off of the package name that was passed to it as the first positional command line argument. That's equal to the version that we passed in. All right, I think this is what we want. Whoops. If we write and quit it correctly. All right, so interesting. Oh, I need to put it in quotes. Still no. Oh, silly me. It's still going to fail because it's not the right version. So if I run it with the older version, 3, EL9 underscore 3. That passes okay. All right, so now the mechanics are working correctly. A couple weird things. Let's get rid of this this output here because I have that stray RPM queue in there, and I think this will do us. All right, so let's try one more time. So if I package test it, oops, with the new version, right, doesn't work. If I do a DNF update less, so that I install the updated version, and then run the package test again. Right now it is running the latest version, so it passes the package test. All right, and I see in the chat Shantanu is uh, giving me a little chiding over whether I quote something or don't quote something, and that's like it's a whole nother beast. All right, so now that we can do this on one machine, what does it look like to do this on all my machines? So let me create a file of machines that I know. Okay, so that's my list of machines that I want to work on. And we're going to execute this script by SSHing into each of these machines and checking it. All right, so, oops, not that one. So what we need to do is we need to take this query format and check to see if it's there and print out the failure or success message. And we need to do that while connected to a remote host. So I'm going to add a little bit more stuff. All right, right? Because we're iterating, we're improving as we go. Okay. So what we're going to do, and actually I already tested this in another window, so I'm just going to copy and paste so I don't typo something and make myself derail the entire episode because I have a copy paste failure. All right, so what I'm going to do is I'm going to replace this if condition with another if condition. All right. So I'm also going to have to add a little bit more structure of, because you notice there's some extra variables that I'm referring to here that I haven't created yet. But essentially it says, hey, if I SSH to this system and I run this command and it equals my target version, then say it's okay. And if not, then it fails. All right, so the other thing we need to do is we need to add some flow control to our script. Right now, the script it runs one time through this if statement. And in fact, we want to iterate through all the machines that are in that file where I listed all the machines. So we're going to add another control structure that's really common for automating things, which is for. Then I'm just going to add a couple of white spaces in here to make things a little more legible. All right. So uh, what for does is it takes a list here at the end, a list of things that it should operate on, and it is a white space separated list. So in our systems text file, there's each system listed on line by itself. So that new line character is the white space character that's going to delineate which of the different systems we want to iterate over. And what happens is each time we enter the loop, we're going to take the next thing off of that list and we're going to assign it to this placeholder variable called system that I named system. And then we're going to iterate through the loop, and then we're going to hit that done, or go back up to the top and grab the next thing off our list, put it in the system variable, run through the loop. We hit done, go back up to the top, grab the next thing off of that list, put it in the system variable, and so forth until we have executed the loop once for every item that is in the list past the loop. All right, so that's where this system comes from. So it's going to SSH to this box. It's going to run this check, and yeah, let's see what happens here. All right, so now we passed the name of the thing, the version we're looking for, and the systems file where we have all of our stuff. Hmm. All right, so yes, hmm. Yes. Okay. Whew. Well, that's not great because I have all this garbage on the screen. I just wanted the okays and the fails. So I'm going to do another thing. Notice I have this variable that I hadn't yet defined called SSH So up a little bit higher in my variable definitions, way up here, I'm just going to make a variable. So what this will allow me to do is when I call SSH, it's going to look up what's in this variable and substitute all these options in. And what it allows me to do is down here where I'm making the SSH, I don't have to have this big, long, disgusting, ugly string of options because I define them up higher. And if I need to add another option in my SSH, like a specific SSH key to use or a user to log in as, I can make it here in the SSH opts variable, and then any place where I use the SSH command later with opts, it's going to pick up those changes. All right, so let's try this. Okay, there we go. So no gross output for interaction, no interaction required for the SSH, it just works. Now, the reason it just works is because we actually did some SSH key exchanges on these two systems earlier. So they are able to authenticate to one another with SSH keys, and those SSH keys uh, either don't have a passphrase or we have it cached using the SSH agent that caches passphrases for using keys. All right, one last thing I'm going to do. So, um, hmm, RHEL client. Did I make it wrong? Looks like it went to the same systems. I bet over here on RHEL client. No, no. Why is it showing RHEL server? That's weird. Oh, I see why. So we said look up the host name, which the first time threw it SSHs to itself, RHEL server. So the host name is correct. The next time it's SSH and done checking over on RHEL client, but then when it's finished with the SSH session, it prints the host name. So I think what we really want to do here is instead use the system that we connected to check. There we go. See, and this is why we iterate. Line 11. Oh, host name system, not host name. Dollar system. Because system is not a command that we want to run. There we go. One more time. Okay. Whew. Man, took a long time. But here we are. So if I go over to the client system and I DNF update less, this would install the updated less, and then I get two OKs. But I would do one more change to my script before I do that. The other thing that I like doing, especially for these ones that report and will potentially go over this big pile of machines and then produce this report, is I want to be able to very quickly and easily visibly see who I have to pay attention to. So the last thing I'm going to do is I'm going to change these two echoes for something different. Something really gross and disgusting. So it looks really gross and disgusting, but it'll actually be pretty sweet. So this string right here, this \033 blah blah blah, this is actually telling the terminal, the bash shell's terminal, what color to use when printing to the bash shell. And so let me just go ahead and run it. So the it's not just the color actually, it's also things like the emphasis. So we can make things bold or other things. So but the code that I put into it only changes the color. So if I had this giant list of machines, what I really want to look for is look for the red ones, the ones that have the fail messages, and then I know which ones I need to attend to. Right. So if I go back over to client, DNF update, let's all right, and then I run the package test one more time. All right, now they're both good, right? Because they both have the targeted version on there. So again, this script is, hey, we have to survey our population of systems to make sure that there is a package installed or is a specific version of a package installed. And there are a bunch of different ways that you can continue to improve this script. One is you could actually make choices based off the arguments. So if the only argument you're given is the package name, less. Maybe instead of reporting okay or failed, you instead want to report the version number of that package from the system. Whereas if you give it a specific version, maybe you want to give it have a failure, and then if it fails, also tell me the version that's installed there. So you can start to kind of customize based off of additional if statements to check conditionals, how we want to output and what data we want to collect. The other thing is instead of putting our systems in a text file and then asking them to pass that out as a command line argument, right? If I know the text file is going to exist, I could just say, instead of positional parameter 3, just cat this file that I know exists. And maybe I put in an absolute path name so that we don't get bit when we run it from another directory. All right, so now I can just eliminate that extra argument, but my script works just the same because it uses this predetermined data. If you don't want to make your own uh, file that keeps track of all your systems, maybe you're able to pull this out of a database, right? So you could use a database query, or maybe you're able to connect to a web app and get a list of servers that your organization has. So something like a curl or wget to make that connection to the web app and then process the data that returns to it. But so these are some two real life scripting challenges, let's say, um, that one could create. And notice they're real small. I will tell you that the color codes right here, I always have to look those up online because I don't remember the syntax for them nor which color, which actual, like right here. So 32 medium width or medium heaviness, that's green, and 31 medium heaviness, that's red. And then over here, what we're doing is we're actually going back to the base font, right? No color font. All right. So we will take a quick look at the chat here. Uh, and I see that Vincent is chatting me about being over 30 minutes. Producer Eric and I talked about that beforehand. So yeah, that's cool. Um, yeah, Shantanu talks about options. So one of the other things that we can do for our scripts is we can actually put in options where there's like a flag, right? Like dash P would be the package or dash V would be the version. That's a little bit more advanced scripting. But if you're making a utility that you're going to use for a long time, that might be worth the effort, right? To put those additional things in there. Um, cool. I will show you one other thing. So let me stop sharing this window and I'll share one more. So I said that it could be useful for doing an assessment of CVEs, right? A CVE affects a certain package, your risk management or your boss, or it's just good. You're a good security admin. You want to make sure that your fleet of systems is not susceptible to that vulnerability, and so you have the script that will go out and report on your fleet. And this is kind of what you would have to do if you're managing a bunch of different Linuxes, because like with Debian-based distros, you could do an apt to or use the apt utility for doing this reporting to get the version and other things. Whereas on Red Hat based distros, you would use RPM to get that information. But if you are a RHEL user, one of the things that comes in your RHEL subscription is this tool called Insights. And so if we take a look at it here, this is the dashboard for my account on Insights. And notice on the dashboard, it says, hey, there's 35 CVEs with security things that you should care about. So you can look at them. And as it populates the list of systems in my inventory, oh, here's a CVE specifically. And there's 81 systems that are affected by this one. So let's look at it. So here's the CVE, and here's how important it is, and here's the exact list of systems that I want to go care about in my inventory. All right, there's also some other stuff, like you can have it print reports for you. So you don't just have to use the web UI, you can actually get a PDF report to hand to somebody, and a variety of other things. So like, yes, traditionally, we write our own tools for these things. And if you're in a multi-Linux environment, you probably do some tooling of your own to account for these things. But RHEL boxes and Red Hat, like, it's pretty sweet. You just go, navigate the web app, bam, here's your report, guy. It takes, I don't know, 5 minutes less to generate the report that you can hand to whoever needs to have it, versus having to connect to every box in your fleet and getting a report. All right. So you want to know more? Awesome. Thanks for making it this far. A couple of things that you might want to go further with. In our last episode, when we were doing a whole bunch of stuff on the command line, one of the things that we used a lot was the grep utility. And the grep utility allows you to take output from something or search through a file for something, and that something is a regular expression. And if you recall, Nate had this really gloriously difficult regular expression for finding IP addresses. How do you make those? What if you're not looking for an IP address? How do I make a regular expression? So there's a couple of articles that I will suggest to you. One is just basically how do you use grep? Using grep on the command line, and searching for text in files. It's a blog that Red Hat has published called Finding Text in Files Using grep. But maybe you're beyond that. Maybe you actually want to get into writing regular expressions. So there's another blog entry that I think is a good start, a good primer on regular expressions, which is called Manipulating Text Grep. So this one talks about like using line anchors to find where this pattern exists, talks about using wildcards, and a few other things that are kind of key to crafting regular expressions. And then the last thing I'll put on there is, so you wrote scripts and you have this pile of tools that you want to manage and you want to put them on your boxes, right? You want to install them in user local bin, because those are places for local customizations for your organization. Well, how do you do that? I mean, I guess you could just SCP all these files around all your boxes, but that's super lame. So I would instead encourage you to look into building an RPM package that includes all the scripts. And we actually have a hands-on lab that will show you how to do it. And so this lab has a couple different types of RPMs to build. One of them is a bash script. You want to just put bash scripts in an RPM. How do you do that? It's in this lab. I would say the lab takes about 50, that's 50 minutes to complete. But it will give you a good baseline on building RPMs. All right. So we'll see you next week. I don't know what we're going to be doing next week, but we'll be doing something for sure. And then also on RHEL Presents, I will be guest hosting. So just like we had a little host swap with Into the Terminal a while back and got Brian Smith and Eric in here on Into the Terminal, I'm going to be swapping out with Eric, and it'll be me and Brian Smith. Who knows what crazy hijinks we'll get up to when talking about the RHEL lifecycle. Specifically, Techmageddon is coming. End of maintenance for RHEL 7. It is upon us in 3 weeks. So if you want to continue getting critical and important security errata, you need the ELS subscription, the extended life support subscription for your RHEL 7 boxes. So we'll talk about that. We'll also talk about extended update support, which is a slightly different thing, and a couple other options for extending the life or better managing the life of minor releases of RHEL as well as major releases of RHEL. All right. Thanks everybody for joining today. And Vincent has another great exam or great guidance. Put your scripts in a Git server. Yeah, you track those things. Also, you might look to see if there's already a script out there on like GitHub that's pretty close to what you want, and then you don't have to write the whole thing from scratch. But you do want to check it to make sure it's not doing crazy things like adding users with backdoors and notifying random servers about data of your server, right? So don't just like pull things off of GitHub and call it good. Like you're going to pull something off of the community, inspect it with your face, and make sure that it works and that you know all the things it's doing before you go ahead and run it on your boxes. All right. Thanks, everybody. We'll see you next week for another Into the Terminal.